Today my guest is Troy Hunt. Troy, how are you?
I'm very, very good, David. A little bit cold in Seattle today.
We're from Sydney. It never snows in Sydney, does it?
No, it doesn't snow in Sydney. Never gets anywhere close to this.
You're the second Australian
Oh, really?
that I've had on this show.
Oh,
Do you know Malcolm Sheridan?
No, I don't.
He's from Melbourne. Good guy.
Excellent.
So you're a security guy, right?
Yeah, so I am a developer security MVP.
Okay. I had never heard of that before today.
No. In fact, I hadn't heard of it until April last year either. So there does exist such a beast, of which I am one. There are a few others of us, and we seem to sort of occupy this little bit of a space between a bunch of different technologies: C#, ASP.NET, and SQL Server, and inevitably we have a little bit to do with all of them in the security space.
All right. And you're doing software development. You're not the infrastructure side of things, right?
No. So this is software side.
What kind of software do you develop?
So I work in the ASP.NET space, so I'm very predominantly web-based. My background since sort of early days of web, mid-90s, has always been the web. That's my passion, and it's just so happens it aligns well with what I'm doing today.
All right. I do a lot of web development myself, and security is sometimes an afterthought in web development. Maybe more often than not.
Yeah.
We actually had a show recently on web security, but it was a short one. A fellow named Bill talked about some of the top 10 security risks and how to address them. But we can go through all of them. Let's talk about some more.
Yeah, sure. So what I often talk about is the OWASP top 10. So OWASP is the
OWASP?
Yeah, Open Web Application Security Project. They're a not-for-profit open organisation, and they set forth a set of what they call the top 10 web application security risks. And they have a nice sort of prioritised list here. And OWASP are technology agnostic. So when OWASP talk about something like cross-site scripting, they're not going to tell you how to fix that in ASP.NET. They're going to explain that in general you have risks around certain areas and you would mitigate it certain ways.
Okay.
And what I've been trying to do is take that and make it relevant to .NET developers so that we've got something that we can refer to in our own language.
Okay. You're actually writing that and publishing somewhere.
Yeah, so all of that is up on troyhunt.com. So I've written a 10-part series over the period of about 18 months. It's all wrapped up into a free ebook of a couple of hundred pages that's available again on troyhunt.com. If anyone wants it, you go and grab it.
Great.
I don't make any money out of it, but people do seem to get some benefit from it, which is nice.
Terrific. Let's hit some of these. What's some of the top 10?
Well, I think a couple of the really interesting ones, so things like cross-site scripting and SQL injection, I think most people have a bit of a concept about them, but the two that I find really interesting that are worth talking about are insecure cryptographic storage and insufficient transport layer protection. So talking about cryptographic storage, what's interesting about this, and TLS when we get to that as well, is that this is about not necessarily have you done it or have you not done it, it is have you done it correctly. So cryptographic storage, I think the thing that most frequently brings people undone in fairly major ways is around storage of passwords.
Okay, so we're storing things probably to a database somewhere, and we're capturing sensitive information, like passwords, credit cards, whatever.
Yeah. So the way we'd approach credit cards would be very different to passwords, and we sort of go down two paths here. So either we're talking about encryption we'd probably use something like asymmetric encryption for credit cards, where we do need to be able to get that data back out again.
Okay.
And we're talking about hashing. So a hash is a one-way deterministic function. It's frequently used for passwords. Now, what I find very interesting when we look at a lot of the breaches that have been happening, and let's face it, there's been a lot of breaches recently that hit the news. Now, what's interesting is that in a lot of these breaches, we're seeing cryptographic storage of passwords happening, but we're seeing it done very badly. So, for example, we're seeing the storage of passwords just as a direct hash, whether that be an MD5 hash, which is most common, or a SHA hash. We're only seeing a direct hash, and the problem that is creating is that because these hashing algorithms are deterministic, so I can pass in a string, and every time I pass in that string, it always hashes out to the same value, which is what allows us to log on and repeat the process and compare what's in storage. So that works great. The problem is that they become very vulnerable to very basic brute force attacks, so things like a rainbow table. So we know from various breaches that people use pretty bad passwords.
Okay, well, rainbow table is what?
So what a rainbow table does is, with the knowledge of there's a certain space that passwords might occupy. So for example, 6 to 8 characters, lowercase, would cover you for a huge percentage of passwords on many websites. So what a rainbow table does is it goes and pre-computes the hashes for every string that fits into that space. So you think about every possibility of A through Z, or Z as it may be, from 6 characters to 8 characters. A rainbow table goes and creates a construct that has a hash of every single one of those, and it takes a long time to actually build that table. But then the rainbow table is able to very, very efficiently take a password list of hashes, compare it to all these pre-computed hashes, and then match and bring back to plain text. Now, you might only get 60, 70% of passwords or something by doing that, because there are people that put in numbers. There are very, very rare people that put in non-alphanumeric characters, and those won't get caught by an attack like that. But it is a highly efficient mechanism in terms of being able to rapidly go through passwords.
Instead of trying to compare the passwords, you're just comparing the hashes.
Yeah, exactly. Now, the other very, very good password hashing tool is Google, or probably Bing as well. But the reason why it's so good is that there are so many hash tables out there from previous breaches where people have gotten themselves a whole list of MD5 passwords, for example, resolved them to plain text through rainbow tables or other brute force mechanisms. It means now that when there's a database breach, it's very, very common that someone will just go and grab one of the hashes, plug it into Google, you get a search back in a fraction of a second that says, all right, well, this is the plain text version for that. So what's really important with our cryptographic storage is we've got to use a salt. So we've got to use a cryptographically random salt.
Okay, what is a salt?
So what a salt does is it gives us unpredictability into the hashing process. So the algorithm's still the same, but what we're going to do now is, instead of taking a plain string, which is the password, and applying a hash, and then, well, the hash algorithm, and we have a ciphertext out the other end, we're going to take that plain text password, we're going to put in this random string, which is our cryptographically random salt, and then we're going to apply that process. Then we store the output of the process, and we store the salt. So when you look at your database, you've got another column. Now, you could still brute force that, but because we've got this piece of randomness, we can't have pre-computed hash tables for it. So what it means is if somebody wants to break one particular password, they've basically got to go through and compute the entire hash table for every possible string plus the salt, and that is a very computationally expensive process. So we're not making it foolproof, but we're making it extremely difficult for people to actually exploit it.
Sure. Yeah, the rule I've always heard is you want to make it more expensive for the hackers to get to your data than the data itself is actually worth.
Yeah, exactly.
That's what you've done, you made it more expensive.
Yeah, and I think that's an important concept across security as well. We're never reaching this absolute point where we say, okay, now we're secure. You're reaching a point where you say, okay, now we think we've made things sufficiently hard enough that it's just not going to be worthwhile people going through the process if they can actually get access to my data to begin with.
Does .NET help us with this salt? I know it helps us with the encryption.
Yeah, so .NET, now what we want to do with .NET is use as much of the native baked-in pieces as possible. And what .NET gives us is they give us the membership provider. So straight out of the box in a brand new ASP.NET web application, if it's not an empty one, and the same thing with an MVC application, is you have got the membership provider baked in, you've got a logon page and a register page, all of this is baked into the framework. You can generate the schema for the SQL database behind that, which will hold that password and that salt and a bunch of other membership and profile-related information, wire them all up. The whole thing takes literally 5 minutes, less than 5 minutes. I've got a video on my blog where I do it in less than 5 minutes. And you have all of this natively. And it uses SHA-1 as a hashing algorithm, which some people think is not enough, but it is certainly a good start considering we've got...
You can modify the code to use a different...
Yeah, you can use different hashing algorithms. You can also go and you can get third-party libraries, things like bcrypt libraries, if you want to use a different hashing algorithm altogether. I think the important thing is, though, is to just try and get people, firstly, to the point where it's not in plain text, and that still happens a lot. Sony was doing that last year. Then to get to the point where you're not just using a direct hash, and that's obviously still happening a lot as well. Yeah. Get to the point where we're using cryptographically random salts, and beyond that, if we can get a stronger algorithm, that's fine. But it's all the low-hanging sort of fruit down here, which is really getting into trouble.
All right. We've kind of drained the hashing algorithm security and password issue. Let's move to something else.
Yeah, so let's have a chat about transport layer security. So when we talk about transport layer security, iOS talks about insufficient transport layer security, and really what we're saying again is not have you done it or not, but have you done it properly.
So this is the SSL, HTTPS thing?
Yeah, so SSL, or as we now know it, TLS, but we keep interchanging the words, they mean the same thing, also known as HTTPS in your address bar. So we're talking about three different things that we get from SSL/TLS. So one of those things is that we get some assurance of identity. Okay, so when we go to a website, we've got HTTPS in the browser bar, and we click on the icon, depending on your browser, we can inspect the certificate, and we can get assurance that we're connecting to American Express, for example. Okay, so we know who we're talking to. Now the second thing is that we get assurance that the data has not been manipulated in transit. So when we load AmericanExpress.com, we are getting what that server has served up, and there is no man in the middle that is injecting things or doing other nasty bits. And the third thing is probably what most people think of, which is we get the encryption, or rather the payload is encrypted in transit, so no one is eavesdropping and casually observing the contents of anything that goes over the wire, whether that be logging on with the password or pulling your bank balance back. So it's important to remember that it does those three things. Now, what we often see done poorly with transport layer security is a few different things. So one thing that we often see done badly is loading logon forms over HTTP. Now this has happened with a number of really big providers over the years as well. So Facebook has done this in the past, and I'll talk about that in a moment. But what this means is that when you type in, in fact, let's use a Facebook example. In the past, if you typed in facebook.com and it loaded the logon page, you could type in your credentials and it would post to HTTPS. So we know that when it was sending your password, it was encrypted. But going back to those three things that TLS give us, we had no assurance that the logon form hadn't been manipulated. So what happened a little while ago in Tunisia, when they had lots of uprisings and political unrest, is the government-sponsored ISPs were injecting script into those pages so that when you loaded the logon page, it's a little bit of JavaScript. So you put your username and password in, and it would grab your username and password, send that off to the government, and then you'd log on to Facebook. So for end users, the experience was the same, but because that page had been manipulated and was doing nasty things, the government was getting credentials. So really important, you've got to load it over HTTPS.
Luckily here in this country, we 100% trust the government.
Of course you do, just like we do. Now the other thing is that once you are logged on, you really need to stay in HTTPS. So a little while back, I think about 18 months back, we had the Firesheep.
Firesheep, I'm not familiar with this.
So Firesheep, and what was I going to call it? The Firesheep incident, if you like. So Firesheep was a plugin for Firefox. And a guy wrote this to demonstrate that HTTPS needs to be persistent across the entire session. So what Firesheep would let you do is you could go to an internet cafe, open up Firefox, have Firesheep running on the side, and it would show you every other person who was on that wireless network who was currently logged into Facebook. You'd click on their name, and you'd steal their session, and you could start posting things around as that person. Now the way that worked is, because we're working in this stateless protocol that is HTTP, the way our requests are persisted so that they, or rather the session is persisted so that it's the same person, same identity, performing activities on the site, is we normally pass information around in cookies. So in ASP.NET, if you're using forms authentication, you'll see there's a cookie called .aspxauth. Now, if somebody else gets hold of that cookie, they then have the ability to take over your authenticated session. So if we send those cookies around in plain text, it's very, very easy for someone to jump in and steal your session.
Okay.
And that's one of the things I did in my blog when I talk about transport layer security, is show how easy it is to do that. So it's very, very important to stay in HTTPS.
Let me just rephrase for a second here. If we're using HTTP, not only is the web page itself sent as clear text, but our cookies are also sent as clear text.
Sure. Anything that's in the request or in the response, including in the headers, is clear text.
Okay.
Very easily observable. Now, .NET makes it quite easy to protect against that, insofar as within forms authentication there is an attribute called require SSL. If you set require SSL to true, it then flags the cookie as secure. So within the HTTP spec there is the provision for a cookie to have a secure attribute, and when that is present the browser cannot access it via HTTP. So go into your forms authentication, set require SSL equals true, and you just literally won't be able to log on unless you've got HTTPS.
But that's not enough. You're saying the entire session should be an HTTPS.
Well, it will make sure that that session cookie can't be transferred over HTTPS. So there's really two parts to it. So the require SSL flag will make sure that you cannot drop back into HTTP.
Okay.
As a developer, you need to make sure then that you're not doing anything like absolutely linking to an HTTP address on your site and expecting people to still be authenticated. So you need to load that logon form over HTTPS, and then, if necessary, use protocol relative URLs, so // path, so that you're never dropping back out into HTTP.
Okay, I see that. I noticed a few months ago, Twitter suddenly, everything, if I typed in HTTP Twitter at twitter.com, it redirected me to.
And
They
everyone
must have learned from Facebook.
I think everyone's going that way, and over the last couple of years, and Firesheet was sort of a bit of a watershed moment, I think, where it was sort of very clearly demonstrated. So, Gmail's all HTTPS, Twitter and Facebook are going that way in parts. Interestingly, Facebook is not doing it in places on mobile devices, last time I checked, so there's a little bit of, oddness going on there. Hotmail is going HTTPS only, so, everyone's heading in the right direction, slowly.
Slowly, yeah. Anything else?
I guess the other thing with HTTPS is don't mix your content. So don't have a page loaded up over HTTPS and then put a great big image in there somewhere that's requested over HTTP, because then your browser is going to throw this big warning which says, hey, you've got mixed content. Different browsers deal with that different ways, but you're going to get some sort of warning, and you really don't want that to be happening. So again, those protocol relative URLs where you just go //. So if you're in HTTP, it'll do it over HTTP. If you're HTTPS, then you'll get it securely. That's the way you want to be looking there.
Excellent. And the rest of the stuff is on troyhunt.com, including your ebook?
Yeah, free ebooks on troyhunt.com. I am on @troyhunt at Twitter. You can find me in any of those places. Email address is there if anyone wants to ask questions or send me things.
Troy, thanks so much.
Thanks, David. So I hope that Technology and Friends is securely implementing their password hashes and requesting everything over HTTPS and not over HTTP.
Thanks, mate.
That was great.